Hello and welcome to today's webcast brought to you by Power Engineering and Clarion Energy Group. Today's event is titled The World's Most Efficient Incremental Power and Steam for Your Plant Profits and is being sponsored by Powerphase. My name is Rod Walton. I'm Content Manager for Power Engineering and PowerGen International, both part of Clarion Energy, and I'll be your moderator for today's webcast. Before we begin, I need to cover a few housekeeping items with you. At the bottom of your audience console are multiple application widgets for you to use. Pretty self-explanatory, but I do want to point out the question and answer tab. If you have any questions for our speaker during the webcast, you can click on the Q&A widget and submit your question. Our speaker will answer the questions after he's completed his presentation, but you can type in your questions at any time during the webcast. You may expand the slide area by clicking on the maximize icon on the top right of the slide area or by dragging the bottom right corner to enlarge. In fact, you can expand and reposition many of the components on your screen, so please feel free to arrange them any way you'd like to give you the optimal webcast viewing experience. If you have any technical difficulty during the webcast, please click on the Help widget. It has a question mark icon and addresses common technical issues. If you still need assistance, just type your issue into the Q&A widget and a member of our webcast support team will work with you to correct the problem. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to all registrants with a link to the archive. It will also be accessible from the magazine's homepage at power-eng.com, E-N-G. So if you want to go back and view all or part of it later, or you want to encourage your coworkers to view it, it will be available for 1 year. In addition, a PDF of today's presentation will be available for you to download. You can find it in the Event Resources area of your console. Now it's time for me to stop talking and introduce you to today's speaker, Bob Kraft. Bob is founder, president, and CEO of Powerphase. He spent 15 years in the advanced aircraft engine engineering arena with GE and Pratt & Whitney. Mr. Kraft also was co-founder and president of Power Systems Manufacturing, including when it was sold to Alstom for $242 million. He has authored more than 25 gas turbine-related patents and graduated with a bachelor's in mechanical engineering from Cleveland State University. Go Vikings! I'd now like to turn the program over to Bob Kraft.
Thanks, Rod, for that introduction, and good morning to everybody listening in the Americas, afternoon to the people in the Middle East, and late evening to those in Asia. I appreciate everybody joining us, and I'm going to really target today's presentation on the economics around our product and some of the ancillary benefits that our product brings to power plants and continuous process. And I'm going to show you how in a lot of cases we're seeing customers that can see basically a 2-year payback with our system while increasing their top line profits. So I'm going to really outline the challenge, at least the way we see and hear from customers, and really go into how we can help that. And again, what value streams do we provide? Just a little bit on how it works, which is my favorite subject, me being an engineer, but also relating those value streams to the product features and how it can turn into profits. And then just a little bit about the company itself, who backs us, and then get into the business case examples. And as Rod mentioned, feel free to ask any questions along the way electronically, and we'll try to hit them either during the presentation or at the end of the presentation. So, there's an interesting phenomena happening, with natural gas pricing, and it's really driving some market changes And there's a lot of development going on in many parts of the world now where there's a significant amount more power and steam required either for just power generation, but we're seeing a lot of demand for process-related incremental steam and power. And, you know, one of the things that is unique about our system is actually the amount of power that we can deliver and the amount of steam. So I'm going to show you, you know, how we can get 15 to 25% more power and steam. And also, you know, it works in conjunction with the OEM's equipment and any upgrades they provide. So it's not a either or. It can be an and. And so I'm going to also talk about how the revenues are improved with our system. So how do we help this challenge for this incremental steam and power? I think the biggest differentiator of our product, and I'll go into this a little bit, is that we really don't require a plant shutdown to do this. We've installed this in a few different places, and basically we've integrated with typical bore scopes and so on that would happen at the plant. And we have several sites out there running our product now, and some of them are running it more or less continuously or have run it continuously for a month or two straight. And we're working with new customers right now where some of the reliability aspects of the plant, namely their instrument air system for a process plant, for example, is a very critical piece. Our system, at the end of the day, is a giant air compressor, and in many cases can supply the whole plant's air supply system as a backup from our system. So avoiding, you know, maybe costly rentals or potential reliability issues there. And I'll show you also some other customers we see that the ability for our system to also generate electricity, which we call a black start type situation, is something else our product does, in addition to the basic power augmentation, steam augmentation. And basically, in the installations that we've had running in the Chicago, Saudi, and Asia, we've basically hit all the different climates that you could possibly have. And you know, in Chicago, we've run at sub-freezing conditions. So there's kind of a thought that our system only works on hot days, because that's how we initially marketed it, from a simplistic standpoint. But the reality is most of these gas turbines, even on a freezing day, are missing a lot of power and steam. So we've demonstrated that. We've demonstrated in the hottest climates in Saudi Arabia. I remember we had to change the color of our hard hats from blue to white because our heads were cooking. And you know, basically the air compression process works the same whether it's hot or cold out. So and the latest one here in Asia, monsoon rains and super heavy humidity helped us, I'll call it, wring out a couple of the last bugs, I think, in our system. But we have a really proven setup now that's actually even more powerful in 2018 than it was last year. It's 30% more output from the same equipment. So I'll go into that a little bit more. But that's how we help. You know, we can give you the power. We can improve the reliability on your air system, and also give you a way to start your plant if you're off the grid. And this next chart here with the clouds on it really just kind of highlights those parts, the power, the instrument air compressor. And when you're in a process-related plant, the gas turbine is really not the main focus. Really, the process is the focus, and the gas turbine is really a non-product cost. It's just a cost. So depending on how the efficiency of the system is measured, we actually improve the gas turbine efficiency. So we can help in situations there sometimes. I'm also going to touch briefly on a presentation that I'm giving at PowerGen, which was really the whole reason for the invention in the first place of our equipment. And it really goes to the grid and grid flexibility. And you'll see, you can't really tell all those little partners in the middle, but a lot of those are backers to our company, big utilities globally that we offer this operational flexibility to. And I'll touch on that a little bit more and kind of give you a primer for what I'm going to present in December at PowerGen. And then, as I mentioned, the black start generator. And let me just say that the black start is, it can be an and, or it can be an or. But in most cases, it's one or the other is really how people would set it up. Deliver the power augmentation or deliver the electricity to the plant or to the grid. It can be dispatched as a reciprocating engine to the grid if the gas turbine's not running. And then on the steam side, our system is mostly gas turbine-centric power, but it does produce more steam. And it has an interesting impact on the duct burner process that a lot of these process plants have a heavy amount of. And because of the thermodynamic effect of air injection, we actually increase the capacity on the duct burner side. And I'll get into that a little bit more. And then, as I mentioned, it is a fuel efficiency improvement on the gas turbine itself, and it's more or less neutral in combined cycle. So this is just a simple schematic of how our system works. Basically, you take fuel in, and it produces about 15 pounds a second. And just to put that in perspective, I ran the numbers one time. It's like 1,000 of the biggest compressors you could buy at a big hardware store, running continuously. And it can deliver air at basically the gas turbine compressor discharge pressure, which ranges from anywhere from a little over 100 psi to could be as high as 500 psi in some aeroderivative applications. There's a closed loop cooling system that pulls water through it, cools the engine and the compression process, the intercooled compression process. And it can either be tied into the plant, or you'll see some photographs here in a minute where we have a dedicated air cooler at ACC-cooled combined cycle plants. And then obviously it generates the air, the hot air, and it can generate about 2.5 megawatts of electrical output and consumes 20 MMBTU of natural gas, the module itself. And the gas turbine, when you're injecting air, just like the gas turbine on a colder day, when it has more mass flow going through it, it generates more power and consumes more fuel. The gas turbine also consumes approximately 20 MMBTUs, depending on which gas turbine you have. So the net effect is the power out and the combined module plus gas turbine fuel. And whenever we quote heat rate on our system, we're always quoting both the gas turbine and the module fuel. So basically, if you look at the output of our system, typically we deliver the air to the compressor discharge plenum, and at a similar pressure and temperature and we're utilizing the gas turbines, built-in mechanical aerothermal combustion capability, where that gas turbine is typically designed for the coldest day operation, several, maybe minus 30 F or something like that. Basically, we take advantage of the fact that there's a lot of mechanical and capacity left in the gas turbine, and a lot of times on the electrical system as well. And when we introduce 10% more air, basically we get about 20% more power, 6% more steam, and a 12% increase in the duct burner capacity, because we lower the exhaust temperature between 20 and 40 degrees Fahrenheit. And if you look at that compared to hot gas path upgrades that we see out there, basically there's about a 5% power increase nominally. They are a little more steam-eccentric, because typically they're involving a firing temperature increase, so they're driving the exhaust temperatures up. So they get a proportionally more amount of steam, and that's why they're typically come with an efficiency improvement. And because of that, you could actually be reducing the duct burner capacity of your system. But if you put our system in with an upgrade, you'd have 25% more power and 15% more steam. So that's a pretty sizable amount of power, and in a lot of cases we've seen customers looking for somewhere in that neighborhood for increasing their product line on a process plant, and we're able to fit in there nicely and do that for them. So, I mentioned that on our air injection system, we really don't have much downtime at the plant to install our system. The other unique thing, you see the 8 little modules there over in the bottom right-hand corner of the picture. There's basically one pipe that feeds all of the gas turbines at the plant, and the system can be sized for exactly the output required. And independent of which gas turbines are running, we can deliver the power to that particular gas turbine, and we've demonstrated that in both of our installations. And the other thing, if you look at just the power density, we really are a small footprint, and unique selling aspect of our system also is when you turn it off and you shut the air valve off, there really is no impact to the plant. So our incremental power and incremental heat rate is really easy to see anytime you turn it on or turn it off. And the other unique thing about our system, and this goes a little bit to the what I mentioned, the original, why we invented it in the first place, was its ability to be quick starting. So the ability to be fast means that it can be used as basically continuous, what I call a continuous power plant throttle push. So where today, you can take it up to base load at some ramp rate, we really just extend that ramp rate with the additional power we have. So, but what's unique about our system is today, to go to, if you want to have 10% reserve, you have to be sitting at 90% load, which is maybe 1 to 1.5% less efficient than base load. With our system, you could be sitting at base load and still have that 10% reserve, but you're getting it at peak efficiency. The other features, as I mentioned, the black start and instrument air really help plants improve their profit and reduce or improve their reliability. And in a lot of cases, kind of make the difference in the business case for some of those I'll call it other features that we offer. So I'm going to go through a few business cases that we ran, and if you want to see the details to these business cases, they are in the backup to this presentation. I'm not going to go through them in details, but you can see the assumptions that we used here if you download the presentation. And the first one is a cogen operation, and it's an 8-module installation at 2-on-1, basically continuous process application. And basically, I take that back, on a 4-gas turbine. It's a 4-gas turbine operation. And basically, the way this plant runs is they never run all the gas turbines at full load. They always have some or one at some minimum load. And when you do that and you look at the heat rate, we can actually deliver the power that gas turbine, that the last gas turbine's delivering with our system, and basically mitigate the poor heat rate that you're getting with that minimum load gas turbine. And this really kind of is a precursor to the utility grid efficiency improvement that we offer. But this is actually at a cogen facility, and even at a really low fuel cost, there's still a huge fuel savings because of the efficiency improvement of our system and the ability to run the balance of the gas turbines at full load while still having the margin and the response of the 48 megawatts that we offer. And in addition to the 48 megawatts, we have 56,000 pounds of steam an hour. And this particular plant also is really looking at a black start system. And here, this $775,000 value that we've assigned is basically a 10-year net present value of if they would have went out and bought that in a diesel genset, basically, and installed it at the plant. So if you just look at the fuel savings, the avoided maintenance on the gas turbine that you're shutting down, some of the expenses the customer had relative to renting backup gensets or backup air compressors for their instrument air system at the facility, and then the black start, it's basically an $11 million annual value that we provide. And if you look at the cost of our system and the operational expenses, the fuel and maintenance of our system, comes out to $9 million a year annual value and less than 2-year payback. The next business case was another industrial application with a single gas turbine in the MISO market on the Gulf Coast. And there you see an image of our module with the air cooler above it. It's a single module with the air cooler. The yellow piping in the front is our gas skid. And similarly, here there's some the way the customer values the steam and the steam production that we provide, and the internal pricing. It's $700,000 of steam value, and by self-generating power versus buying it off the open market, in their market, just looking at their annual pricing on average, there's about a $600,000 saving there. And then also this plant had some air compressor rentals. So again, if you look at the value that we provide, it's about $1.8 million a year of value. It's a single module. And if you look at the operational expenses of our system, again, it's about a 2-year payback. And then the last business case, first picture, upper left-hand corner is Mexico Beach on October 11th. And I actually happened to be at a wedding in Tallahassee. And I wasn't able to even drive over there because of the convoys of help that was coming from basically all directions. But I know what I was thinking about on October 10th. I was thanking God it didn't hit where I live. But these, there's a lot of process applications along the Gulf Coast there that I'm sure we're watching that storm very closely. And we have one customer in particular over there that we're planning on putting our system in next year that they basically have a mandate to have black start there. And it was actually a result of last year's hurricane that hit them. I forget the name of it. But they were out of power for 7 days. While the grid was still coming back up, they had 7 days where they weren't able to run their process. And we don't know the exact value of that ourselves, but it's in the tens of millions of dollars of revenue and profits lost. And so the ancillary benefit of black start to them is a priority, and they also need more power and more steam. So when you look at the in this particular application, they're going to run it intermittently and play the market with the power sales in the ERCOT, and but they also value because they're a process plant. There's a high value on the instrument air backup, and again, like I mentioned, the black start. So similar to the last business case, it was about $1.7 million annual value stream to these guys, and when you reduce that by the OPEX, it's about $1.5 million a year, and again, about a 2-year payback for our system in that application. So just a little bit about Powerphase. In the last 18 months, we've brought on a series of strategic investors, and we're actually in the process of bringing on some more right now. Basically, all these guys here are, with the exception of Burns & McDonnell, are global utilities. And we also have some direct investments from Clear Sky and Excel. And basically, we have programs with most of these guys where we're offering similar to that 8-module case that I showed you, where we offer the flexibility and the efficiency improvement. We basically are basically a 2 to 3 year payback in most utility environments, where we basically put 10% more power across the whole fleet of combined cycle plants. And when we do that, for every 10 combined cycle gas turbines, they shut one off. And when they do that, there's while providing the same reserve, which they do by having these gas turbines running at part load, we provide that same reserve by having our system on top of a running power plant. If you put in there on top of that we call it our black start system. We'll probably rename it for that because they're going to be using it for renewable response when their gas turbines aren't running. We'll be able to generate the power and put it on the grid for that purpose. But when you look at that combined package, and in some of these markets where there's a high renewable, we're less than a 3-year payback for a utility putting it across their whole fleet. So that's where we're really headed with this product. That's what we had been targeting since the beginning when we came up with it. and I think next year you're going to start seeing that come to fruition. A little bit about the background of the company itself. You heard my introduction. I think it was fair. Kirk is on the phone. James Kirk Duncan. He's our VP of Sales, and Jim, CFO, and Diego is our project director. And you know, all these guys have been, including myself, have been in this type of business for a long time. And then I'll say maybe even more impressive, but at least just as impressive is our board of directors, which are guys who help guide the company strategically. And for example, Mark Little and Bob McGrath. Mark was the Chief Technology Officer and ran the power group for GE for 10 years and 15 years as a Chief Technology Officer. And Bob McGrath was a EVP at NextEra and was responsible for putting, I think, 26 gigawatts of wind and power on the ground in the United States. So, and then Jack Egan is, he ran an EMC for more than 10 years. He was in charge of sales there. So we have a serious board that really helps us, I'll say, get the message out at the right level, especially with the utilities. It's so just a little plug for it's my last slide, second to last slide. A little plug for the Power Gen presentation. We're basically going to be co-presenting with Excel, and we're going to show the economics backcasted for 2017, where when they put Turbophase across their fleet, how much fuel are they going to save, how much emissions they're going to save, and how much ratepayer are they going to save when they put 10% more power across their fleet and maintain and improve, actually, their responsiveness to renewable energy fluctuation. So that's going to be at 11 o'clock, I think, in Orlando. So if you're interested in that, I'd welcome you to come see that and meet Kirk and myself there. So the next steps in the final chart here is anybody who's interested in a site evaluation, we're going to offer that complimentary to anyone who would like to have that. And you know, the way we'll do it is we'll set up a call, either myself or Kirk or both, to really walk through the business case with you guys and make sure that we're taking everything into account, and then we'll set up the site visit. And our contact information is there. And also we have complimentary passes to PowerGen if anybody's interested. Contact Kirk or myself, and we can get you passes. So really be interested to hear back from anyone who's interested in making more money, needs more power and more steam as soon as next year. So with that, I'll open it up to any questions.
Okay. Bob, thanks for a great presentation. It was really kind of amazing to see those details about Mexico Beach, and also hear about the utility support that's underneath Powerphase as well. And thanks for the PowerGen plug there as well. It's now time to move on to the question and answer portion of today's presentation. We have a lot of questions lined up. If you haven't already done so, please enter your questions by clicking on the Q&A widget and typing it in. We'll respond to as many questions as time allows. And we'll go ahead and get started here, Bob, with first question, which is, when you say no plant downtime, what do you mean? How do you install it?
Yeah, so I'll give you, for example, the first system we ever installed was in Chicago, and we did the outage over about a 3-month period of time while the plant was running, and that particular plant had 3 gas turbines, so they always had one offline, and so we made the tie-ins when the gas turbine was down for other reasons over a 6-month period, and we hooked our stuff up, and about 3 days after our modules actually showed up on site, we were generating power at the power plant. The actual tie-in time took less than 2 days total from the time they shut the gas turbine off. So, if the gas turbine is coming down for a normal bore scope or some other event, we just coordinate with the plant to make our plant tie-ins at that time.
All right, thank you. Great answer. Let's go. Can you really install something in 2019?
So the answer is, our advertised lead time used to be 6 months. We've kind of stretched that to 9 months. But yeah, we have several customers we're going to be signing later this year and early next year. That'll be in and operating next year.
Very good. Great. Got a question here. Can the technology be used for the solar Taurus, Mars, and Titan machines?
The answer is yes, and we're actually working with a couple different companies on that, and we have basically the blueprint. We haven't built one yet, but the blueprint for what we call a Turbophase Mini. But we do have a site that's got multiple smaller machines that we'll put one of our modules there and feed all the machines. But the answer is yes.
Okay. Next question. Can I keep using my same gas turbine parts?
That's actually a significant positive benefit of our system, and the answer is yes. A lot of customers, especially in the process application, want the older, more reliable gas turbines and really don't go for the latest and greatest because they want to make sure that the reliability requirements are extremely high. And our system literally, when you put in say 5% more air injection, 10% more power, we're really making the gas turbine think it just got maybe 20 degrees Fahrenheit cooler outside or something like that. So you don't have to change your turbine parts when you do that.
Excellent. Another question here. Have any utilities installed this, and can you talk about that a little bit?
So the quick answer to that is no on a utility, but we are in process with several, and the power generation business in general is a very slow to adopt, and utilities are at the very tail end of that slow. So it's an extra slow process for them. But we have support all the way to the top at a couple of these utilities, and I think next year we should see some hit the ground in the U.S.
All right. Next question is actually two, so break this up. We got number one. What is the temperature pressure of the instrument air? And bonus question part of this is, can you have just the Powerphase as a standalone generation unit if you do not have a combustion turbine?
So the first part of that is that when you're using our system as a backup instrument air, we deliver the air at 100 degrees Fahrenheit or less. If you have a lower temperature requirement, we can hit that. But typically the ones we've looked at have been 100 degrees Fahrenheit and a minus 40 F dew point, which meets the most stringent instrument air requirements that we've seen so far. And we can deliver it at pressures anywhere from 100 to 500 psi, depending on what the plant requirement. Typically, they're, less than 200 psi. And the second part of that question, can we use it as a standalone generator? And the answer is yes. It's actually interesting you asked that question because, like utilities, process plants are also very, very conservative on reliability. So showing our system as a genset or a backup air compressor is very low risk, but also adds the benefit of having this additional power and steam capability. So it's a way to kind of overcome and show the plant and get them comfortable with the system. So the answer is yeah, you could put our system in for an instrument air and black start system and have it as a power augmentation system as a backup or as a second phase or whatever, if you will.
Okay, excellent. Next question, what is cheaper over the long term, this or an OEM upgrade? So
it depends on how you define it. I think, OEM upgrades, if you're after efficiency improvements and a little bit of power, they're not bad, and they if you're going to be replacing your turbine parts anyways, depending on what they're giving you and how they're pricing that to you, could be less expensive than our system. Could be more expensive than our system, depending on how your pricing and your service agreement is. Our system is, we think in a lot of cases we're less expensive, but like I said, the real differentiator for our system is we are a lot of power, and we offer a lot of ancillary benefits that you don't get with just an upgrade. And in a lot of cases, especially different parts of the world, different types of process plants, they want the older, I'll say, less efficient. Less efficient means more exhaust energy, which drives their steam process. So, it really is a customer-dependent answer. It's hard to really to answer that question for everybody. It's different.
Okay.
But we're something different. We offer a different value proposition than they offer.
Right. Next question. Overall heat rate, is it better or worse after the install?
So if you're looking at just the gas turbine, which, a simple cycle application, or in some cases cogens where the steam and the gas turbine power are really segregated into value streams, we are a heat rate improvement on the order of 2 to 3% with a 5% injection rate, 10% more power. And if you look at it in combined cycle, our track record so far is, we guarantee that the plant heat rate doesn't change more than 50 BTUs when you do our 10% more power. The reality is that we're very close to maybe slightly higher than a combined cycle application. But also in a lot of those applications, they're running a lot of duct burners, and we are significantly more efficient than a duct burner operation. So when you look at how you would operate your plant, you have to consider whether you're running your duct burners or not. I would just make the statement that we're definitely more efficient than a power plant with duct burners.
Okay. Okay, another question here. Can we have the backup, that's asking, can we have the backup for your business cases?
Yeah, actually, the next 3 slides of this presentation are the backup for that. And if you go on the Penwell or the Powerphase website and download this presentation, you'll see the calculations.
Okay. The next question I'd like to know the answer to is, what is EIP?
EIP is Energy Impact Partners. It's the name of a fund that has those 15 or so utilities as investors in the fund. So that's how we're associated with those 15 utilities, plus Burns and Mac that I mentioned. And then, as I also mentioned, we also have direct investments from Excel and Clear Sky, which represents, it's a wholly owned subsidiary of NextEra Energy.
Right. Okay, and coming up now, a question, with that much power and steam increases you talked about, what's the revised system thermal efficiency? How much drop would be expected, and the greenhouse gas emission impact of that?
So, you know, on a per megawatt basis, you know, because our efficiency is similar to the combined cycle efficiency, if you're looking at it a combined cycle standpoint, which I'm assuming the question is coming from that because of the steam, you know, we're more or less similar. So, like your power plant makes so many tons per hour of emissions at a certain megawatt rating, and if you're making 10% more megawatts, you're making 10% more pounds per hour. So the parts per million stays the same, but the pounds goes up because you're just making more. Ours is virtually identical to that. The unique thing about our system, really, we found is that we're really more of a gas turbine-centric power system, whereas I showed you on the OEM upgrade, they're more of a steam cycle or bottoming cycle because of the exhaust temperature increase. And we actually decrease the exhaust energy. So I actually think in a lot of cases, you'll see an OEM upgrade go in and then basically run into some plant limits on the bottoming cycle. And we tend to see that a lot less because we're not really, I'll say, driving that bottoming cycle that much harder. For just to say it out loud, for every 10% more power we produce at the plant, about 3% more steam production. Whereas if you look at an OEM upgrade for the same, you know, maybe call it for 5% more power, the steam cycle might be making, you know, the majority of that. So we're kind of the opposite.
Okay, here's a different question. There are some U.S. Navy ships that are propelled by gas turbines. Has the Department of Defense expressed any interest in this upgrade?
We really haven't approached them. It's something we've thought about because they also have generators on board. We can do both, but we really haven't focused in that area. Like I said, our really focus is at the utility level, and then also at the cogen and power for grid applications, where we've been really focused. So I think they could use it, but we really haven't pursued it a whole lot.
All right. I hope somebody from the Navy is listening. How can we get, next question, how can we get 20% more power without upgrading the generator? How much margin do existing generators have to deal with that?
So I've actually done that before. So on a simple cycle 7FA, we put 20% more power out. Maybe on your, on a cold day when you're already generating close to the maximum output of the gas turbine, maybe you have some limits there. But also, since we are a separately fueled source, we don't have any real power draw from the plant. I mean, our typical module for us is anywhere from 35 to 50 kilowatts of auxiliary power per module, which is more or less 5 megawatts at a combined cycle plant, between 5 and 6. So basically, we can incorporate refrigeration processes that we have some IP around, because when you get into some really hot environments where literally there might be 25 or 30% more generator capacity available if you could cool it, with a separately fueled system, especially something that incorporates a refrigeration process, maybe you can address those cooling requirements. So, but I've seen 20% more generator capacity on a 70-degree day on a 7FA simple cycle gas turbine. So.
Very good. I'll try to, I'm going to just say this next question verbatim, hopefully get it out here right. You are saying that the system produces 25% more steam. If yes, then does this increase the mass flow out of the turbine? Would this also reduce the temperature of the exhaust flue gas, causing superheating problems? Is this correct?
So the example where I was showing 25% was actually using a Turbophase system in conjunction with an OEM upgrade. And in that case, basically the OEM upgrade was increasing the exhaust temperature, and then our Turbophase system basically negates all of that increase. So it's basically unchanged. So from a temperature standpoint, it's unchanged. From a mass flow standpoint, there is a mass flow increase on the steam cycle. So the balance of plant has to be looked at to make sure that all the equipment can handle the increased steam. And again, that's a unique aspect of our system is you could actually add more of our stuff and less of their stuff and really tailor the amount of steam production you get up until you hit a plant limit. So it's not just one size, or it's not one piece of equipment that does, call it 10%. If you needed 5%, we could do 5%. If you needed 12%, we could do 12%. So it's a modular solution that we work with very reputable engineering companies to work on the balance of plant and evaluate. And that's part of our site evaluation is we'll look at that stuff with you guys.
All right. Well, looks like we have time for one last question today, and I'm going to go ahead and ask this here. Long term, how does Powerphase see its? There's a word missing, but I'm going to guess future. Long term, how does Powerphase see its future as Turbophase becomes more widely used? Is it looking to be bought out by a larger manufacturer or grow and support this item as a long-term product?
So anyone who knows me, I'm a kind of a long-term guy. And, the vision for the business really, as kind of I alluded to in the beginning, was to have this fleet reliability for renewable. And I don't think we missed by much what's happening in the market with respect to that globally. There's a lot of renewable going in. And I think we are an extremely cost-effective solution to the existing infrastructure to make it significantly more resilient and reliable and flexible to that generation requirement. And I think we haven't advertised a whole lot our black start and instrument air stuff because we really just wanted to focus on getting some installations in with the baseline product. But I think the next stuff you're going to see at the utilities is going to be very, with the black start, with the air compressor, with the air injection. We also have another technology that we actually just got the patent awarded on Monday for, which is going to basically allow us to extend that rapid power generation to actually steam injection. So, steam injection is something that some plants do already, but it's never used in a regulation type environment. And just to say it out loud, in the utility environment, our system would run very infrequently. And if we could double the output of our system by having this rapid steam injection capability along with our air, basically it cuts the cost of our product in half. So I think we're going to see a 2 to 3 year type payback go to 1.5 year type payback, and hopefully next year we'll be showing that at some utilities. So I think the thought is that in the future, what I'd like to do is to continue to bring on strategic investors who are going to install our product. And anybody else who knows me knows I like to fish. So hopefully someday I get to go fishing. But I'd say the goal is to bring on strategic partners, and when the right time comes, we'll know it. And I would say also, I did learn a lesson from my last business. It really wasn't able to be acquired by a large OEM because of the competitive nature of the business. And this business, we really did set it up with the thought in mind that eventually it would end up with one of the large OEMs. So, one of the requirements of the business was it had to be complementary, not competitive. And I really believe we are complementary to what the OEMs have to offer.
Well, sounds like big news, big opportunities there for the future. Thanks for those great answers, and thank you, audience, for some great questions today. Fortunately, we didn't have time to get to all of them that came in. So if your question was not answered, Bob and his team will try to look at it offline and respond to you. On behalf of Power Engineering, PowerGen, and Clarion, I want to thank today's presenter, Bob Kraft. I would also like to thank Powerphase for sponsoring today's presentation, the world's most efficient incremental power and steam for your plant profits. Remember that a PDF of this presentation will be made available in the Event Resources tab. Just a quick note that he referenced earlier, Bob is a speaker in the Knowledge Hub at PowerGen. I believe it's Wednesday, December the 5th, if I'm correct. And also Powerphase is an exhibitor at PowerGen, booth 1631. PowerGen International will be December 4th through 6th in Orlando, Florida. Hope to see you there. Okay, so now this webcast presentation will be archived within 24 hours and can be accessed from the homepage at power-eng.com, E-N-G.com. A reminder email message for the archive will be sent to all of you who are registered. It will include a direct link to the archived webcast. Please feel free to share the link with your coworkers and peers. I want to thank all of you for joining us today. I know you're very busy. I appreciate you taking the time for this presentation. Look forward to sharing future webcasts with you. I'm Rod Walton. Have a great